Okay, all right. So before we start the class, so please make sure in your own environments that you installed pandas, and also this pandas underscore data reader, and also fix underscore Yahoo underscore finance, because we are going to play with some stock data sets. And also make sure you have the latest version for the GitHub repository of the course. So you can either say git pull if you already have it, or you can say git clone, right? Okay, everyone is doing that? And also, for the final exam, I'm not going to ask you how to use NumPy or pandas, okay? So I already sent you a material to prepare for. So yes, it's going to contain some algorithms, but those algorithms are really, they should be really easy for you. You know, they should be like high school level algorithms. And you should be able to implement them using Python. So this is good for you, so you'll be better prepared for coding interviews, okay? Of course, it will be just a start. You know, you'll need to do a lot more for it, but I hope it will at least encourage you or give you some ideas about how to prepare for. Okay, so if everybody is done with these installs, let's continue with NumPy where we left off. So we need to import NumPy as like conventional way. We just say import NumPy as NP. So in NumPy, it's actually important to make sure the shapes match, because remember it does the element-wise computation. So let's say I have this A matrix, array, and if I say print A, so it is like this is the array for A, right? I just say np.arrange. But if I try to sum it up with another array, which is two-dimensional, it will actually give an error, because one is four-dimensional, other one is two-dimensional, right, as expected. I mean, there are cases NumPy adjusts to the shapes when you have different shapes, but it's called broadcasting. That we will talk about it later. Okay. And also, NumPy has its own function called np.sum. For example, if I have an array of this 1, 2, 3, 4, then I can actually just use this NumPy's summation function just to sum up the values. So it gives the values to you right away, just summation of all these values. Okay, so it's NumPy's built-in function. And you can also do this, since A is an array, is an object, you can actually say just A.sum. So it also does the same computation. Okay, so in NumPy, so let's say you have like a two-dimensional array. So when you say NumPy.sum, which axis is that gonna compute the summation over? So the rows are called axis 0. If you want to do summation over rows, you call axis 0. If you want to do summation over columns, you call it axis 1. So for example, if we do summation over axis 1, our results are going to be like 2 and 4. if we do it over axis 0, our results are going to be 3 and 3 for this two-dimensional array. So you can tell this to NumPy. So let's create an array called, so it's going to be exactly this array actually that I just show here. So we can write it as like 1, 1, 2, 2, and say A. Oh, I said, let's make it 2, 2. And then, so if I want to do NP sum of A, so if I want to do for each column, what axis should I say here? So based on what we have here, so for each column, right. So gives us 3, as it should be. And so we can actually do the same thing in order to by using sum for each column. So for example, if I want to get a 0th column for A, I can just say comma 0 dot sum. And if I want to get the summation over the second column, I can just say A, sorry, not column and 1, and then I say sum. Does the same thing, but it doesn't return you array, of course. It returns you a tuple in this case. This gives you an array. Okay, so if I want to do summation for each row, what should I say for axis? 1, right? And we can do this doing each row, so we can get the 0th row. I mean, the first row with 0 index, and then you can say sum. And you can do the same thing for row 1 and do sum. Oh, yeah, it was a mistake. Okay, so it gives us the summation for each row, like this case. So we do it over axis 1. Okay. So by default, we can actually check what it is by default by just typing np sum question mark it is interesting. It says none by default. Oh, okay, so let's try without giving it anything. Let's say np sum A. Oh, it actually sums all the values when you don't give anything. Okay. All right. So of course we can do other reductions too. So let's create an array again, which is going to be the values of 1, 3, 2. And then in order to just get the minimum of it, you can just say actually np min, np dot min of x. So it gives 1, of course. And you can also do np max to get the maximum value again. Gives the maximum value, which is 3. And do you know what to get for the index for min? Do you remember? I mean, it's actually a mathematical thing. So if you are looking for a value that minimizes a function, what do you use? So if you want to get the index for the minimum value, so this is the array, and the minimum value is 1, so you want to return 0. So 0 is the index for the minimum. Yes, argmin. So this is the same thing in calculus too, right? And for the max, you can do the same thing, which should be 1, because maximum value is at index 1. Okay? So these are other reduction operations in NumPy. There are also logical operations like np.all. So for example, this checks if all the values in your input are actually true. So in this case, of course, it is going to return false. But if you are fine, even if one of these is true, so you say np.any, so this will return true. So any is like OR. It does the OR over all your inputs, which are all Boolean. But for all, it is like AND operation. So it makes sure that each one is true. If one of them is not true, it returns false. Okay, so we can use this for array comparisons. So let's create an array of zeros. Do you remember how to create a NumPy array of zeros?
Yeah, zeros.
Right. And then I give the shape, right? And this is actually how it looks like. Everything is 0. So you want to check if any value not equal to 0. So can somebody walk me through this? Not equal to 0, but any value. Right.
It should be false.
Right. And if you want to check if all values equal to 0, based on what we just learned, and P, we say all, right, this time, and X equals 0, right? Okay. All right, so let's take a look at these 3 arrays here. So A is 1, 2, 3, 2. B is 2, 2, 3, 2. C is 6, 4, 4, 5. So if I run this, what is the output? First, before running, first try to see what it should be. So let's break this problem into smaller problems. So if you look at A less than B, A less than or equal to B, so is all elements of A are less than or equal to B. So it's 1 less than or equal to 2, yes. 2 less than or equal to 2. 3 less than or equal to 2. 2 less than or equal to 2. Okay, so this is all true. So let's look at this one. B, 2 less than or equal to 6, right? So we are comparing B and C now. So 2 is less than or equal to 6. 2 is less than or equal to 4. 3 is less than or equal to 4. And 2 is less than or equal to 5. So this is all true too, right? And when we have this AND operation, everything here is going to be true. Then when I say all, should be what? True, yes. I didn't run this one. Okay. All right. So that was about logical operations. So let's do a little bit statistics, the most basic statistics. So we can define array again, let's say 1, 2, 3, 1, and another array of y. So I can actually just compute the mean of x by just running that mean. Or you can compute, by the way, so I can either say x dot mean or I can say np dot mean. They are the same thing. Okay? Or I can say, if I want to look for the median, I can say np dot median. So it gives the median. That's strange. 1, 2, 3, 1. Hmm?
The median should be the average of 1, 2.
Oh, yes, right, because it is like so there are 4 elements here. So we are actually looking for, so it could be either 2 or 1, that's why we are taking the average, right? What about this? So, okay, so we have y here, right? So let's see how y looks like. So this is what y looks like. So let's first compute a median of this y for each row. For each row, I want to compute the median. So what input should I enter here? X is 1 or 0? 1. For each row, so it is like I'm doing the computation over x is 1. So it should be 1. Okay, so it gives me 2 and 5, which is correct. Okay. Or you can also say just x is minus 1. That actually knows that it's the last axis. Same thing. You know, so don't get confused if you see x is minus 1. Okay. And we can also do the standard deviation. You know, you can just say x dot standard deviation. It gives you the standard deviation of the array that we had here. Or if you want to compute the standard deviation across rows or columns separately, you can just input this axis information. Okay? All right, so now we can finally use the data that you pulled from the GitHub library. So it should be the data in populations.txt file. So for example, here I'm in my lectures, Lecture12 directory. So in my case, it should be like, I should go one up, and then it's in data directory, the populations.txt. So this actually describes the populations of hares, lynxes, and carrots in northern Canada during 20 years. So you can basically just look at the data in your editor, or we can also see it here too. So for example, in my Python notebook, I can just say cat of this file location. So this is how the data looks like. Okay. So can everybody get this data? Is there anyone who cannot get it? Okay, what's the problem? Why can't you get it? Did you pull the repository? So are you able to access the data?
I think so. The path is all funky.
Yeah, so you may need to change this path.
Yes.
So wherever you pulled the, or wherever you cloned the repository, you should change this according to that repository.
Yeah. Yeah, I got it.
Okay. All right. So we can actually load this data set using NumPy's load text. So let's call it data np load text and data populations.text. So let's see how it looks like. Okay, so this is how the data looks like. So see, it actually converted it to a NumPy array. And here you see that, so first column is like years, second column is one species, third column is another species, and so on. So here, let's look at the transpose. Do you know what transpose means? Everybody? Transpose of a matrix?
It's like when you switch it, right?
Yeah, so you have this matrix, you just rotate it like 90 degrees. You know, so every time you rotate your images 90 degrees, you're actually taking the transpose. Okay, so I can actually take a look at the transpose. So for the transpose, you see, so whatever I had in the first column, when I did transpose, it actually gives me the first row. First column became first row. Second column became second row, and so on. So now you'll see why I'm doing this. So now I'm going to use some trick, and I'm going to assign year and all other species carrots to this data.transpose. So let's take a look at them now. So this is how year looks like. So basically, this assigns each row to the variables that you specified here. And we can look at hairs and so on. Okay? So we have all these 4 small data sets. The first one is year, the others are populations. Do you need some time? Yes. Okay, so let's wait like maybe half a minute. Let's check Instagram. So can everybody see the data and load it to NumPy? No? You can load it to Python. Okay. So then what we did is actually we just use this NumPy load text to the location of this text file, and then we have been analyzing it, and finally we assign each of these variables to the numbers in this text file, where we have year and all 3 other species. So now let's play with plotting functions. So for this, remember, we need to import from matplotlib first. So we can actually say plot year and what was the first one? Hairs. So let's give it a label. Hairs. And plot year. Second one was lynxes. And let's do the last one. Carrots. Carrots. And let's say let's also tell Python to give the legend. And also let's say X label is year. And let's say Y label is population. Okay. Should be fine. Yes, it worked. So here you see that how the population changes for each year and for each species. I wonder what happened at these time points. Maybe there is some causation here. When there is an increase in hairs, then carrots increase too. You know, so you just do some data analysis based on this. So let's look at the mean populations over time. So let's first create a populations data from this data set. So remember, in our data.transpose, oh, I don't need transpose actually. I can just say 1 to 2. So basically, I want to skip the year. I only want to get the populations. No. So what was the original data set? Sorry, it's okay. So original data set looks like this. So I want to get. I just want to skip the first column, but I want to get all the other columns, but I want to get all the rows. So should be this and 1, 2, 2. Okay, let's see how it looks like. Okay, looks right. So here I only have the populations data. So now let's look at the mean of each species, mean population of each species. Let's change this to mean. So I'm going to say NP mean, right? And basically I'm going to say populations. So okay, so for each species, how do what axis should I give here? So each column is a different species.
0.
You say 0? Why?
Because each column is a different data point.
Right. So we need to do the summation or computation over rows, which is axis 0. Right. Okay. So looks like this. And we can do the same thing for the standard deviation. Just say population axis 0. Right? So this gives us the standard deviation. Okay, so what about this? What species has the highest population each year? So imagine we represent each species as like 0, 1, 2. So what would you do here? We want the index of the highest population of a species. Argmax?
Yeah.
What axis? Right. Why 1?
We're trying to find the max in each row.
Right, right. So for each row, we want to find the max that represents the column of the spaces with the highest population. Okay. So 2, 2, 2, 0, 1. All right. So let's talk about this important concept called broadcasting that you will probably hear a lot in NumPy and also extensions of NumPy. So as you have seen, basic operations on NumPy are actually element-wise, and this works on arrays on the same size. But it's also possible to do some operations on arrays of different sizes if NumPy can transform them so that they have the same size. For example, so if you look at each of these cases here, let's say you have this matrix, and then you have another matrix, right? So, okay, so this one is not that interesting, right? It just sums everything element-wise, and it gives you this result. But if you have this matrix and you have this array, which is just a row, when you try to sum them up, NumPy actually creates a virtual matrix of that, where each row is like 0, 1, 2, so they match the shape, and then it performs the computation on that, which gives you the same result. Okay? Or if you had this column and this row, when you try to sum them up, NumPy actually creates this matrix, this virtual matrix, and also this matrix, and then does the summation element-wise to get the same result. So basically, even the shapes don't match, NumPy can create a matrix that that has the same shape of whatever array, or sorry, whatever matrix you are giving, and then does the computation element-wise. This is called broadcasting. Okay, so let's look at examples. Okay, this must be too small now. Ooh, too big. Okay, create an array of 0, 40, 10 using np.tile and transform. Okay, what does np.tile do? Let's first take a look at it. Okay, so it constructs an array by repeating a, the number of times given by reps. Are there any examples? For example, if you have an array like this, 0, 1, 2, when I say np.tile of a2, it actually just creates just repeats whatever you give. But if you say tile 2 by 2, so it repeats the row, and it also repeats it repeats both row and column. And then you can even give for more dimensions. Okay, so let's create this matrix. Okay, I didn't explain it, but what I meant was np.tile 0, 40, 10, so I want to create for each row and not for a column. Let's check if yes, that was right. So basically here what I'm doing is I'm repeating this row like 3 times, and by just taking the transpose, I'm basically just transposing it. So let's see how it looks like. Okay, so this is what I generated by using tile.
What's in the tuple, the second argument, the reps? Why is it 3, 1? I know 3 is like 3 rows, but What does 1 do?
So if, let's see what it does if I say 2 here.
Oh, so it just repeats as many times. Okay.
Yeah. But I don't want it to repeat for the rows. Sorry, columns. So I want it to be to repeat only like for each row.
Oh, okay, I see now.
Yeah. Actually, if I don't have transpose, maybe it might be easier. So here, this was the array, repeats it like 3 times. If I had 2 here, that could have repeated on here too. So you will have extra column. But I want to transpose this. So I have this value. And now let's create array of a different size, which is 0, 1, 1, 2. And if I say, okay, so now they are clearly different shapes, right? One is a matrix, one is just a row. So now let's say a plus b. Do you think it's gonna give an error or do something? Hmm?
Or on campus?
Yes, it will give a matrix. So basically, so it takes this array 0, 1, 2, adds it to the first row, adds it to the second row, adds it to the third row. This is what we got. So this is like broadcasting. Okay, so let's have another example. Let's say an array A of ones with size of 4 and 5. So I can actually assign just a single value to the first row. Their size don't need to match. So look at, so A0 is like a row, right? So I'm taking the first row, and then I'm assigning 2 to that. And when I plot this array for the second time, you see that it actually replaced all the values in the first row with 2. So you don't really need to repeat 2 many times. It just knows what you are trying to do. Okay.
So if the A is not a ones array, can we still do that?
Yeah, of course. Can I say this random dot rand? Oop. Okay, let's do it in a separate. Let's say let's call it X and P random. I want to use rand, and how do I give the shape of this? Two by 4 array of samples. Oh, okay. Sorry. Okay, I can just say 2 by 4, for example, or just say like 2 by 5. Let's say X. Okay. And now X looks like random. And then I can say X 0. 999, and if I look at X again, see, so it changed all the values in first row. So it doesn't matter if it is ones or anything. So as long as it's an array, it works. Okay, so let's look at this. Create an array of 0, 40, 10. So if you look at the shape of this, it's going to give you this. So you see it is not like 3 by 1, just says 3 dimensional. But you can actually add a new axis to this. Okay, is this right? Let's see. Okay, I need to check that one. Oh yeah, that works. So I can just assign this to all the values and np new axis. So now if we look at the shape, now it became 3 by 1. So this is like some trick that I also recently learned. To make it actually, instead of making it like just 3, nothing, we just made it 3 by 1. And when we print it, it actually looks like this. Now you see we have extra brackets here. Oh, I made a mistake, sorry. So this is A, this is the shape of A. Let's call this B. And then create B. Okay. And then look at B. And now if we look at A plus B, so remember, one is like 3, nothing, other one is 3, 1. So now we are gonna say A plus B. What do you think it should output? Okay, so basically what it did is, so for each row, each value, it actually created a matrix, and then it did the summation element-wise for each of these values. So we have 0, 40, 10, 0, 40, 10, and then so we added only 0 to that one. And now we added 40 to the second one, and we added 10 to the third one of the original one. Okay, so let's make it a little bit more useful. Okay, so let's construct an array of distances in terms of miles between the cities in of Route 66. So we have like Los Angeles, Flagstaff, Santa Fe, and all that. Okay, so let's have the miles like, so these are the values. So if you imagine Los Angeles is the first one, so the second city from Los Angeles, so Los Angeles is like 0 distance from Los Angeles, right? And then the second one is 198 miles from Los Angeles, and all that. So if you run this, so what is the shape of this? It is 10, nothing. But what if I actually add a new axis? So let's call this new miles. Okay. So if I look at new miles, you see it is more like a column now. So if I actually make a computation between these two, so milepost is just this one, and new miles is exactly the same thing, but just with a different dimension. So in this case, the dimension is so it is 10 by 1. So when if I actually compute, so if I actually first compute the difference between those two, one is 10 by nothing, other one is 10 by 1. So it's going to be 10 by 10 because they are like different shapes. So NumPy creates matrix for each and then does the element-wise operation. So we can actually now compute the distance between each city. Remember, so our first milepost was just the distance from LA to all the other cities. That's why it's actually increasing. But what about the distance between Chicago and Santa Fe? All that. So in that case, we actually, what do we need to do? We need to compute like difference between each of these, right? So I can do that by, let's say, distance array. And it has to be absolute value, right? Distance should be absolute. And I can actually take the difference. So that computes the distance between each of these values. So we can actually look at the distance array. This is how it looks like. And of course, the diagonals are going to be 0 because each city is only 0 distance far away from itself. But then you see like the distances between different cities. So each row and column is actually a different city here. So maybe we should plot this. So let's say plot imshow distance array, and also let's add a color bar. So here, so each of them is actually a different city. Each row is a different city. Each column is a different city, and we can actually see the distances between each of those. Yeah, I think distances get smaller as you go to east, I guess. Let's look at. Anyway, maybe I shouldn't overinterpret this. But this is how you plot it, and this is how we use broadcasting to compute difference between each of the values of an array with itself. And also, you can do some array shape manipulations too. So let's create another array from 1, 2, 3, 4, 5, 6, and let's look at or just plot it maybe. So this is the array we have. We can actually flatten this by just using this revel function. So I can just say a.revel. So it actually creates just like one-dimensional array when you say that. And then we have been using transpose anyway, but you can just say a.t. It just transposes the matrix. So from here we have this. All right, what does it say? First transpose, then revel. Okay, so what about a.transpose.revel? So now you see that, so it actually does the flattening of this matrix. So it takes first 1, 4, and then 2, 5, and all that. So basically the higher dimensions, the last dimensions level out first, basically. Okay, so reshaping. So check shape of A. I hope A is this one. Okay, so we can create a B by using Gravel. Okay, that's we have been doing this anyway. So we can actually let's first take a look at B. So we can actually do B dot reshape, and if I want this flattened array to be 2 by 3, I can just say reshape 2 by 3. Now I have the matrix again. I don't think we need to print. Or if you just want to say I want it to have 2 rows, but I don't care how many columns it has, so you can actually say, in that case you can say b dot reshape 2 and -1. So it is unspecified. And in that case it knows the same thing, because it still gives you 3, because once you say that you need to have 2 dimensions, then it can only have 3 dimensions to fit the array. Okay, so it is about reshaping. And of course you can do sorting too. You know, for example, if we have an array like this, and then you can, if you want to do sorting, okay, so what do you think the values of B should be? So assume sorting is ascending order. And I do it axis 1. What is the first row? First row is 3, 4, 5. Right, so it's gonna sort first row, and then so it's gonna sort over columns. So over columns, the first row is gonna be 3, 4, 5, and the second one is gonna be 1, 1, 2. Okay. Or if you want to do it in place, okay. So let's look at A first. Okay, so A is still like original. So what if I want to do in place sort? Then if I look at A, oh wow, see, so this when you just run it like A dot sort, it actually does it in place. So it has modified the array. It's something you should be careful. Okay. I think you can read these ones. It's like finding, so arc sort is going to of course give you the indices of your sort, and you can still get you can still use like arc max and arc min to get the indices with maximum index and minimum index. No, so not that interesting. All right, so let's move to pandas now. So how many of you have used pandas? You? Okay, so you already know. So this is used for data analysis, especially for tabular data. So basically, whatever you can do with Excel, and probably even more that you can do with pandas. So the conventional way to import it is just like import pandas as PD. I mean, if you want to look for more tutorials, you can actually take a look at this link later if you want to become an expert with pandas. But today is going to be more like an introduction, what you can do with that. So pandas has data structures, of course. So one data structure is called series. So the way you create a series is, let's say, x pd dot series, and then you create these values for 7 minus 5 3. So now I can print these values. So you see it actually has these values of 4 7 minus 5 3, the values that I assign, but it also has these extra values here which indicate the index for each item you have. So like index of 0 is 4, index of 1 is 7, and so on. So we can just print the values. You see that it's actually a NumPy array. So usually pandas and NumPy go together, or maybe, okay, so pandas actually depends on NumPy. So they use lots of tricks from NumPy. That's actually why they are computationally efficient. So we can also print the indices or indexes. Like this. Okay, so pandas is smart that it's actually, instead of giving me like 0, 1, 2, it knows that, okay, I know it was like automated and it's just like a range from 0 to whatever number you give me. But we can actually change this index. This index is not that interesting, right? Just like 0, 1, 2, 3. So what if you want to have a panda series with I think what were the values? For 7 minus 5 3, you can actually say index A, B, C, D. Oh, I know. Okay, what do you think I made wrong here? I made a mistake. Right? So it looked for variables A, B, C, D. And since I defined A, B, C already, but only didn't define D, got complained. But we want them to be strings. So we can actually take a look at B. So now this is how the panda series look like. It's more interesting now. So these are A, B, C, D are the indices, and these are the values. And if you just want to see the values again, you can just say B dot values. And if you want to see the index, you can just say A, B, C, D. And if you want to access the value at index A, you just say, oh, B was a really terrible name for this. Anyway, you can actually say B of A. So it knows that 4. So the index A had a value of 4. So this is how you can actually retrieve that information. And I can also call all these values. So now I'm only getting the values for the indices at this order, CAD. Okay, so what about I want the values that are greater than 0? Only greater than 0. Any ideas? You can just filter it. Okay, so it is very easy. You just say b greater than 0. And it gives you the values that are greater than 0. And if you want to multiply all values, let's say by 2, all you need to do is b multiply 2. So it multiplies each row. And you can also say, if you want to check a certain index is here, for example, you can say d in my series B. Of course, it's going to give true. But let's say you say E in B, it's going to give false. Basically, it is to check if that index is in your series. Okay, well, you can actually create a series from a dictionary. So let's say I have this dictionary S data, where it is like keys, Ohio, Texas, Oregon, Utah, and values are this. I don't know what they are, maybe populations. But anyway, so we can create another data. Let's give it a better name. PD series, and you just say S data. So now it knows that your indices should be the keys of the dictionary. So this is how it looks like now. It automatically knows these should be the indices, these should be the values. Create a series from S data with states of this. Okay, so what is happening here? So the original dictionary had these values, but now I'm gonna create another series from pandas series. So I'm gonna give this dictionary S data, but as an index, I'm gonna give these values states. So it already has these indices, but I'm forcing it to use these ones. But for this, okay, Ohio should be fine. I already have Ohio. Oregon should be fine. Texas should be fine. California, I don't have California, so it is probably create some California as an index and assign nothing. And we have Utah here, but we are probably not gonna use it. So let's see what happens now. If you look at another series, see, so we don't have Utah anymore, and instead we have California, but we don't have a value for it. That's how pandas assumes with the missing data set. And we can actually check if like PD is null. What was the name? Another series. So you see, it knows that, so I'm checking if it is null. So for California, it is true. Yes, we don't have a value for it. So that's why it is true. And others, we have values, so it is not null. So it's false. Okay, so you can also do that by just using another series is null. So just different way of doing things. It's either pd.is null this or another series dot is null. Okay, so we have this another series, which is like California, Ohio, Oregon, Texas, and we had the original data series, which was Ohio, Texas, Oregon, Utah. So we can actually sum them up, but we have some missing values, some nonce, all that. So let's see how pandas handles that. data series plus another series. Okay, so for California it is none because it was already none anyway in the another data set. So none plus anything is none. Ohio, okay, so it actually computed the values of Ohio in both series. And same for Oregon and Texas. But for Utah, we don't have the values of Utah in another series, so we get none for this. Okay, use name attribute for the values. What do I mean? Okay, I think I just want to assign a name to that. So for that, let's say another series that name is population, and also another series that index that name is states. Okay, so now let's see how it looks like. Okay, so now see here, I can see, oh, okay, its name is population, and for the index, okay, now it is more descriptive now. It actually has this name as states now, right? Okay, so this was all about pandas series. You can actually also create a data frame. So what is the difference? So the difference is that in a series, you realize that we have only one column of values. But what if you have multiple columns, right? What if we want to have population, number of, I don't know, number of cars in that state or whatever. So each column is something. Then you will need to use this pandas data structure called data frame. So in that case, you can actually create it from a dictionary. So let's say we have a dictionary which has these states. And also year. And also population. Let's give it a better name. Okay, so this is the dictionary. I have state, year, and population. And then I can create data frame, let's call it DF, using pandas data frame from D. Okay, and now if I want to print the data frame, you see that it actually looks more like an Excel data. So we have all these like states and year and population. So obviously this is like the population of state Ohio in year 2000, population of state Ohio in year 2001, and so on. Okay, but here I actually want to change this index. I don't like this 0, 1, 2, 3. So we can actually create another data frame. Why does it? Okay. Let's say PD. Sorry. Data frame. What was the? Is it dictionary? Yes, D. It was just D. And I say columns are year, state, population. Oh, okay. So I'm also adding another column. There was state. Okay. State, population, and let's add another column which is not in our dictionary, which is that. And also let's create an index. Which is 1, 2, 4, and 5. Okay. So let's print this again. Okay. So now I changed the index, and I have everything as before, but I also have this extra column which doesn't have any value, of course, because my dictionary didn't have it. That's why they are all none. So if you want to print the columns for this data frame, you can just say df states. Oh, sorry, it wasn't df, right? No, it was df. Oh, it was state, sorry, not states. Okay, so it actually gives me pandas series. When I just say state, it gives me the result with the index information too. And you can also do this by just saying df.state. Gives you the same thing. So you can either use this expression or this expression. What's the difference between retrieving and printing? Oh, okay. So here, actually, what I wanted to do is df.columns, literally print the columns. Okay, and here I wanted to do this one. Just doing a tiny bit cleaning so you don't get confused. Okay, so this should go here, and this should go here. Okay, we are good now. Okay, so these are for the columns. What if I want to retrieve the rows? So you can actually do this by using this block. So df.log, for example, let's say 3. So it should give me these values here. That's the index I'm looking for now. Okay. Okay. And you can also give the index of the index. So basically, you can use df ilog. For example, 3 corresponds to 0, 1, 2. So if I look for ilog at 2, it should give me the same thing. You know? So if you want to use the index of the row, you can just use ilog. But if you want to use the name, you can use log for pandas. So now we can actually assign a value to the column det by just saying this equals to 16.5. Or you can actually do, you can assign an array to this. Oh, first let's look at how it looked like, our data frame. So see, it actually assigned this value to each row of that. What if I want to assign values from like 0 to 4, including 4? In that case, you can just say np arrange 4 or 5. 0, 1, 2, 3, 4. So I need to say 5, right? Let's let's see. Okay, so I can assign those values too. All right, what does this one say? Assign true if state Ohio to a column Eastern. That does assign true if state is Ohio. Okay. So we want to create a column called Eastern, which doesn't exist. Yes. If this and it should have a true value if Ohio is the state. So did you understand what we are trying to do? So we just want to add another column that says Eastern, and we want to assign true if it is Ohio. So basically it should be like true, 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 false, false. Any ideas?
Can you apply a filter, like a mask?
Yeah, but pandas actually is it's designed to make your life easier than that. So basically all you do is you say df Eastern, and if df state
Use log. Use log to do it.
why lock? Lock is for rows. We are creating a column now.
Yeah, but like you choose the row that will stay.
Oh, you want to do a for loop and
Yes.
yeah, I'm sure you can probably use it, but it's a lot easier than that. So here, all you say is Ohio. This is equal to Ohio. So create this column and make it true if this is true. If not, it's false. You see? So that's why it actually makes your life a lot easy if you want to do these kinds of filtering or selection operations. Okay, am I going too fast? I feel like I'm gonna run out of my materials soon. Okay, so of course, statistics, descriptive statistics is a big part of pandas. So let's now, what does it say? Create a data frame from this list with the index A, B, C, D, columns 1, 2. Okay, so let's say we have this. And let's call this df again. And I'm gonna say pandas data frame. So it's gonna have L for sure. And for columns, I'm gonna give it a name as so it's going to have 2 columns, because you see this is the first row, and like first column, second row, first column, second column, and so on. So for columns, let's say 1, 2, and also for the index, let's assign A, B, C, D. Okay. So now let's print this. Okay. Nice. So we have 1, 2 columns, A, B, C, D in the indices, and these are the values. So we can actually just do column sum. So basically, I want to do which one do I mean here? Sorry. Okay, so actually here I want to get the sums for each column. That's what this means. Maybe I should change it like sums for columns. Okay. So what do you think? sum, but you should probably give an index, axis. Hmm? 0, right? Remember that figure was like 0, 1.
Yeah.
Okay, so for each column we have the sum. Is it true? Okay, so here notice that for example for column 1 it actually ignored the NaN value. It only does a summation over the values that it had. It skipped the NaN. And of course you can say the same thing, same summation for axis 1. Yeah, let's change this. Sums for rows. Okay, so it gives us the row summation for each row, and again it skipped all the NaN values. But if you can actually say skip NA false if you want to consider those NaN values. If you want to get a value of NaN, then you can say skip NA false. So compute mean across which one? Let's see. Okay, so let's do the mean for each row. So you just say df mean axis, and let's also have skip NA false. See, now we actually see these NaN values because we have this skip NA false, and these are the mean for other rows where we didn't have NaN. Okay, so you can do the same thing like index max. Did I mean arc max? Yeah. Let's see. Oh no, actually it's index max. So it is like to get the index that gives you the maximum value. So let's say df index max, let's say axis 0. So it will give us for each row. So it is like B and D. What does that mean? So for each column, it says the value which has the maximum for 1 is B. The value that has the maximum is the one that's D. Okay, so that's what it does basically. So it's like arc max from NumPy. And you can also do the cumulative sum. So if I say cum sum, so actually it just like takes this and then adds the values whatever you had here. So if you want to see what D was like, so df was like, so it adds these two and then assigns a value 8.5, and then this is NaN, it's gonna skip it, and then for the last one it actually adds all the available values here. So it takes this one, and this one and assigns a value, and same for the second column. So it's like cumulative sum, like cum sum. And you can actually just use this describe to get the summary statistics of a data frame. Let's say this. So it actually gives you all this information about the statistics. So for example, for column 1, that means you have three values which are not NaN. And for column 2, you have 2 values. So these are the counts. And these are the means, standard deviation, and all that. Okay? So you can get all this by just saying describe. Okay, so at this point, you should make sure that you have this pandas underscore data reader installed. Okay, and also this fix Yahoo Finance installed. Okay, so let's run this. Yeah, pandas used to have a way to get the stock values before, but they changed it, and then someone else wrote this pandas underscore data reader, and then it also had a bug, and then someone else created this package that fixes the Yahoo Finance thing with that package. So this is a little bit a hacky way, but that's really not the main important main message here. So how many of you are interested in stock prices, data, things like that, business, finance? Okay, just one person. I mean, they are doing good in US, you know, you should pay attention. Okay, so let's get, is there any stock you want to check? Like any of your favorite? Let's see if you can get it.
Amazon.
Yeah, me too. What is the, how do you write Amazon for A-M-Z-N? Oh, okay, good. Okay, so what is the start date you want to see?
August 15th.
Okay, so 0/15/2018.
Sure. I do today.
Let's say 15.
Yeah, whatever.
Okay. So let's say values. I don't know, what should I call it? Better name. Or my stock. So I'm gonna use data. So that's the function I should use is get underscore data Yahoo. Okay, so ticker, start date, and date. Okay, good, it worked. Hope we got the values we were interested in. So let's say my stock. Let's also change this one. I mean, let's just, so in pandas you can actually just say hat if you don't want to see all the values, but just to get an idea about the data, you know, because I don't want to print all the values. So let's just say hat. Okay, so these are like high values. Oh, really? So this is when it was closed, and you know, so we have all this information. Good. And actually, I'm curious. Let's do my stock. I want to plot it. Let's see. Okay, you know, it's, yeah. Is this right?
No, that's right.
Is this right?
Yeah, it did like a couple weeks ago, and back in August it was like 4,000 or 5,000. Yeah, it looks great.
I see.
I'm looking
Okay.
at it right now.
All right.
It's just like a closer picture.
Nice. Okay, that's fine. So now let's actually create. Let's look at more stocks. I mean, these are the ones that I put, but obviously, if there is anything you want me to add, I can replace this. I mean, any other stocks you are interested in? Huh? Okay. What else? Tesla? I don't know how Tesla is. You don't want it. Anyway, okay, so for the same dates, okay, so let's create a all data dictionary, empty dictionary. And now let's get the stock information for each of these. So let's say for ticker in all this, okay, and let's assign a value to that. Let's say let's get this one, and I'm gonna use the same dates. Okay, is there anything else? This is the last time you can change the stock names. If there is any other company, let me know now. Okay, so let's get all this information. Oops. All the data. All right. So now let's create a data frame price for the close price of each ticker. Okay, what should we call it? Oh, it's actually already says price, right? Let's say price. So we are going to create a data frame. Of let's say ticker data close for ticker data in all data items, right? So basically I'm iterating through my all data, and for key is going to be ticker, and it's going to have the data, it's going to have this data which is going to be I think data frame, and from that data frame all I want is just the close price. Let's see if it works. Nope, didn't work. What did I do here? Oh, I'm sorry, I forgot. Okay, so I'm actually making it a dictionary because I need to give something like a dictionary to the data frame as an input. Okay, so let's see what I got here. I'm gonna say hat because I don't want to. Okay, so for each company, each date, I have the closing prices. Okay, but we are more interested in the percentage returns, right? Those values by themselves are not that interesting. So now let's call this returns. So in pandas, you can actually just say price.percentage change, because that's a very common thing that we compute. And then we can look at how it looks like. Again, I'm gonna say head. By the way, you can say tail too. Yeah, if we do tail, we will see more recent dates. See, minus, minus, minus. Okay. So what if I am interested in the correlation between these companies to get an idea? Do they go together? Do they increase together, decrease together? So Pandas has this correlation function. I think that's it. Yes. So this will give us. Oh, look at this. I mean, I think this is pretty high. Like Microsoft and Amazon are very correlated, and Amazon and Google are correlated too. Looks like IBM is not correlated with anything. Apple has less correlation. Yeah, this is interesting. So Google and Microsoft seems to be the most highly correlated. Anyway, so so this is how you interpret results. You can do covariance too. Do you know the difference between covariance and correlation? So it's from statistics. It's like one of them is zero mean, one of them is not zero mean. I mean, it's not our subject, but you can, if you want to do covariance, you can actually just look at this too. So correlation is normalized. So the highest one is 1 here. But when you do covariance, for example, with itself, that's the this gives you the standard deviation basically. Sorry, variance of this company. All right, and if you want to look at the correlation of all companies with let's say, let's change this, with returns Amazon. Okay. So here I can actually see that Google is the highest, IBM is the lowest correlation with the Amazon. Okay. You like Apple, right? I know. Which one? Yeah, kind of. Yeah. But correlation is not causation. So we don't know which one triggers what. Okay, so we can also plot all these, right? So let's say plot. Oh no, actually Pandas has its own plot, so we can just say returns.plot, and let's also give it a figure size 15:6. See, so this is how they look like. So they fluctuate. Yeah. Anyway, you can interpret it as much as you want. Or in terms of returns, you can just, as long as just one company, can just say Amazon plot. This is how it looks like. Looks like a noisy financial data, actually. All right, so it was about financial data sets. So now let's also see how we can actually read data in Pandas. I mean, so far we actually just got it from Yahoo Finance, so we didn't read any data. We actually downloaded it from the web by using those packages. What if we actually want to read the files we have? So basically, for example, for this, we can read the populations data. For that, let's call it pop pandas. So you can say read CSV basically, and then let's say data populations. And then if I look at the results, oh, it looks horrible, you know. So I forgot something here. I forgot to put the delimiter. So basically it should be tab. It is probably using something else by default. So I need to tell it, no, delimiter is actually tab. Now let's see. Okay, now it looks better. So this is how you can read the data. You know, we did this in NumPy, but you know, Pandas actually has more functionalities for these kinds of data types. So let's look at New York City 311 noise complaints. Hey, have you ever done this? Noise complaints? Calling 311, complaining to the police that there's so much noise on your street. And I do this every once a couple of months, actually. It's too noisy. So actually, this is the source of the data is this. So now let's read the data. Let's call it complaints. Pandas reads CSV. So it is still under my data. 311. Okay, let's see if I need to do anything with the, okay, it's like complaining that there are some mixed types. I'm fine. Let's see how it looks like if I need to do anything with the delimiter. Okay, it looks fine to me. Looks like unique key, created day, whatever complaint type. So now let's only select the ones about street or sidewalk noise complaints. Let's say, let's call this noise complaints. And complaints. Okay, so I only want the ones that actually say noise, street, sidewalk, sidewalk as a complaint type. Any ideas? So all you need to say is you want complaints where complaints are of complaint type is actually equal to, what was it? This one. Right? Okay, now let's print it. All right, so now they are all noise, street, sidewalk complaints. Good, that's what I wanted. And I also want, I don't need all these columns. I just want these ones. So let's call it data. Data, noise complaints. Wait, why is it, did I do insert? Anyway. So I don't know what happened here. Data equals, okay, noise complaints of these ones. Okay, and let's take a look at the data. Okay, so now I have more compact information. And so let's see, we want to know how many noise complaints each borough has. Any ideas? You can use value counts, value underscore counts. And I only want this for the borrow information. So for each borrow, I actually want to say value counts. So how many that will give me how many complaints I have for each borrow. Okay, first of all, I need to get the borrow, right? Is it okay? Okay. Okay. No surprise, right? But these were just the noise complaints. What about the other complaints? So what is the ratio of these noise complaints to the total complaints? There are so many other complaints too, right? So let's call it it's a ratio. Any ideas what to do here? We have a data of complaints too. Just the ratio. So since this is going to be a ratio, I definitely need this one, right? Can just do the same thing, but just say complaints. Let's change this to here. Okay, so now ratio is going to be this. So these are the ratio of noise complaints to the total number of complaints we have. And we can actually do a bar plot of ratio. We can just say plot. We can say kind bar. You see for Manhattan, it's obviously like the ratio is a lot higher for the noise complaints compared to the other ones. Okay? Any questions? No? Yeah, of course, there are a lot more about pandas. This was more like an introduction for you. So if you feel like you need to use this, so these are more or less the capabilities of pandas. And then you can actually learn more about it by going through the tutorials and all that. And you can do pretty much most of the basic data analysis with pandas, unless they are like big data, you know. All right, that's all for today. Okay, fine. And for the final exam, don't forget, I'm not going to ask pandas or NumPy. It's going to be more algorithms and all those questions I provided for you. Okay? All right, thank you.
What's the form of the final exam? Selection question or handwriting the problem?